All right, thank you. Greetings, and I need to turn this on. Greetings. So this is mixing in Elixir to build search. Today is Friday, the 16th of March. We're at Codebeam, San Francisco. So I'm Adrian. I'm a software engineer on the search and personalization team, building pretty much all things search at Teachers Pay Teachers. You can find me online at Cruz. So just a quick update on what Teachers Pay Teachers is, just for context. We are a marketplace for teachers to buy and sell resources that are education related. So quick stats, 2 out of 3 teachers in the States have used Teachers Pay Teachers to buy or sell resources. We sell similar things like this. So consider myself, I am not a teacher, but pretend I am a primary 7 teacher. And I'm not a design savvy person, but I want to teach my students slope. So I've did a quick search on Teachers Pay Teachers. I found this fun little product where I can teach them how to do slope while killing zombies. So pretty fun. So mixing in Elixir, what does that mean? For TPT, we are on an old monolith, and that means by breaking it. And considering that Teachers Pay Teachers has been around for quite some time, that means there is a big monolith that we broke by piecemeal. So that means some of our pages are still running our Cake PHP app, and some of our new pages are on Elixir. So let's talk about search, just so you know what we're building. We click on the search bar. What we see here is Autosuggest. This is a screenshot taken fairly recently. So we see some searches like St. Patrick's Day. I know that's in a couple days. So we've got some seasonal data. And then other popular search terms as well, like spring, Easter, also seasonal. Fractions are still apparently very popular. So let's begin searching. So now, pretend I've typed in math. And what happens, you see a giant list of more things that you want to have search for. Let's zoom in a bit, just so we have more context. We see other search suggestions. We see St. Patrick's Day math is seasonal, but also still popular, and it has math in it. So other related math games, math centers, math worksheets. They're search-related searches. We have seller suggestions with math in their store names, in case the user is looking for a specific store that has math in it. And we have this facet called a type of resource. We have math centers, which happens to be a type of resource. So the data to power that is nothing out of the ordinary. This is what you'd suggest, what you would expect. We have your sellers, your resource types, and your lists of searches that are related. You have the links and the links for the thumbnails to also power that data. So here's the process to power Autosuggest. We're a Google Analytics Premium user, so all of our data goes to BigQuery. We have an ETL data pipeline called Forklift, which writes a table to a database, and Autosuggest read from that. Now, Autosuggest is built on Phoenix. So, Autosuggest, it's a standalone service that we've built out in Elixir as a proof of concept. Like I said, we have not been using Elixir for too long. This is the one service that we wanted to try out. If it fails, we'll just revert back to our old Autosuggest. If it succeeds, then that's our proof of concept for management. Be like, okay, this is Elixir. We can do this really well. We're going to move forward with Elixir. So big shout out to my teammate Samir for owning this project end to end now. But you can see why we chose Phoenix and Elixir for this. Autosuggest, if you think about it, you type any sort of character, it'll hit that endpoint. So it needed to be robust, it needed to stay up all the time. So that was Autosuggest. We're going to now talk about the information retrieval part, and that's basically the search. So this is a very simplified version, but we have a MySQL database with their product data. It gets ingested into Sphinx Search. Sphinx Search is one of the less popular search engines than Lucene or Solr, etc. It speaks a MySQL protocol, and PHP it speaks that all right. And CakePHP is our monolith that we're breaking. So CakePHP had all of our search, our product pages, our homepage. I think you get the point. So, implementing Morse Elixir. We've decided to move forward with a GraphQL API. And with that, we started using Absinthe. So mixing in GraphQL. So now we have our MySQL database with our products. We still have Sphinx Search, which still speaks MySQL protocol. Our issue with being able to speak that and support GraphQL was that we had to fork MariaX. We're using MariaX to talk back to Sphinx Search and our MySQL database. But to support Sphinx Search, we had to make some updates. So our fork of MariaX is now what we call SphinxX. We had some updates be able to go upstream into MariaX, but other ones not so much because we were told that they're not looking forward to supporting extra rows is pretty much what it happened to be. Our front end is running React now, and it runs Apollo client, which is able to query our GraphQL. So that gave us a whole lot more ability to debug and analyze search. As a search team, as a command line tool, just to see some quick metrics, Cowboy was thrown in the mix so we could have a interface to see the quick data. We built out some more tooling on the more personalization side, just so we could do a lot of heavy querying on the GraphQL that we're doing, and lots more personalization tooling. So this is a quick look at Graphical. This is a very simple query. This will actually work. We are able to send in a GraphQL query, and on the right, we'll be able to see some results. So a complete decoupling of front end and back end. So I can test GraphQL queries, which is essentially testing our GraphQL API. And that was something that we were not able to do in CakePHP. When we were testing for weird search results, we would have to go on the site and just do a random search and then say, is this issue a front-end issue or a back-end issue? So having a decoupling of front-end and back-end really helps. So that's how search became easier to debug with that whole big decoupling. But it's also now easier to test. So this is a very simple test that we have in our smoke tests. We have Jenkins doing our builds, and we're running a GraphQL query against our code that they want to deploy. And for this, we're testing a specific facet of grade level 1 to 2. So what's expected is that you're going to get 2 facets returned, and it's going to be grades first and grades second. So if you happen to have broken that, the smoke test will complain, scream, and your code will not be deployed. So, also, testing our search terms has also become a lot easier. So, a lot of our search, obviously, we have Autosuggest, but they're all just basically strings that are coming in. And what we've done now is just taken that string and converted it to an abstract syntax tree. So ASTs are very helpful for us on the search team to be able to just define what the exact search term is And for the more advanced users of search, if they're doing negative search, we could also see that. So to say a quick example, so say a string of this and that is being searched for. We get an AST. We get a word of a char list of this, a word of char list of the and, a char list of that. So consider a quoted search of this and that, and then you get a quoted AST of a char list of this and that. And for the more advanced negative searching, where you want this but you don't want that, we also do support that in our search. The thing here we're doing is an AST not. So ASTs are very helpful when we're pre-parsing the data and then sending it back to Sphinx search. And that was able to be easier to test quite a bit more. So we've have in our test suite a whole lot of input that we find as nice inputs, and I guess bad inputs in case somebody's trying to game the system or send some malicious search queries. Luckily, we sanitize all that and handle that all properly. So consider that this previous test, it's a for a loop on what we're doing to assert, and we'll get an OK and what's expected. So consider we have a search for fractions, cheese, bananas. We have a fun team that like to have fractions and cheese and bananas, sure. But we'll also expect the specific AST returned. So let's move on to the search analytics part. Search is not easy. On our team, we do a lot of A/B testing. I mean, a lot. So this is our search replayer tool that I was talking about. We do a lot of internal eval. This was all previously a command line tool. We're able to just pull up quick metrics on any sort of changes we're making. Like I said, we do a lot of A/B testing, so if we want, we could change the ranker A version, ranker B version, etc. And that's the replayer part. It basically takes that configuration and replays that against what we have as top 100 searches, top 100 one-word searches, two-word searches, top 100 browsers, which is just facets. And that runs all of the GraphQL queries with the specific configuration and gives us some aggregate data. And no search team would not be complete without a side-by-side tool. We're able to just go through similar A/B configuration and see them side by side. And we're able to say, OK, in this variant of this search test we're doing, the algorithm brings less free items, or this one brings some of our top sellers out of page one, which in a marketplace, that's a big deal. So not something you really want. So a quick example on how we do replaying on the top 100 browsers. We basically take the facets, which would be considered a browse. We do task async, so we could parallelize all those GraphQL queries against our database. And we do some updates and get some aggregate data. It kind of looks similar to what's here. We do a big query, but this is more or less what the data that we want. We want to know what kind of views each has, price, sold, how many free items are on the search pages. And we get something similar to this. This is mock data, but you could tell that, OK, on page one, on the A variant, the average price is $9.36. On the B version, $12.80. We do a lot of A/B testing, kind of get to consider, all right, well, this was a lower average price. That must mean that our users, kind of liked more of the cheaper items. That's perfectly fine. So a lot of our items that people like, more on the free side, and that's perfectly fine. So this just helps drive the conversation on, which test will win if after the 2 weeks of analysis. So mixing in Elixir for tooling. The tools that I just spoke about, they were actually written in PHP. The parallelism was not quite available, so now we can. So luckily, we don't have to wait hours for our aggregate data to come and return back to us. So, and also, it's just wonderful for onboarding and learning Elixir. So one of my teammates took it upon himself when he joined. He said, "I don't know Elixir, but let me rewrite this in Elixir." So let's move on to a case study. We have something called related searches on the bottom of our search pages. It was initially an SEO initiative just to be able to link back to other search pages. But remember, it's now we have in place a new system. So building this was very easy. So just a refresher on what I spoke about earlier. We have Autosuggest that's running Phoenix, and we now have our GraphQL API. On our GraphQL API, we're able to run a query like this, and we have in our config the URL for our Autosuggest, and it's basically querying it. And that's it. It's as simple as that. And on the React side, it runs a GraphQL query, and it's able to give you similar results from what we've got from Autosuggest. Slightly different variant from Autosuggest. We do slightly different things for Autosuggest, but it gives us the related searches that we want. So for PyDay, here are your related searches. So this is Elixir mixed in. We're about a year and a half in using Elixir at Teachers Pay Teachers. These are lessons we learned. Autosuggest was definitely a great pioneer to help us push Elixir forward. If we failed with Autosuggest, then our options were pretty much, all right, let's just revert. We'll choose another language. We're happily not failed with the Autosuggest, and we've moved forward. So, GraphQL API, definitely decoupling things, has benefited us magnanimously. It's wonderful just to be able to test front end specifically or back end specifically. Having a system that's, I think, 10 plus years old, I was not part of that, but it's a lot easier to be able to just have services that are not coupled together. So I talked about a little bit of the learning. A lot of us at TPT just are starting learning Elixir now. Onboarding by bootstrapping projects is one key thing that we've thought were really helpful for us as engineers to learn Elixir, as well as watching conference talks like this, or lunch and learns, and basically just code pairing with more senior engineers with less senior engineers. So we've blogged about quite a bit of our journey at engineering.teacherspayteachers.com, engineering.teacherspayteachers.com. There is a reference for the Maria X and Sphinx X fork that we have on there. I highly recommend that as a good read. And that's all I've got. Thank you. Yes.
So I just had a quick question. So for your front-end test, are you basically just testing that the query gets built right from the UI, and then that's what you test on the front end, and then your back end, do you have like a live test server running where you return the results?
So the question was, if I've understood correctly, on our front-end tests, are we just making sure that the query is just built properly? So for that, we have end-to-end tests in React, running a test suite, and similar smoke tests. And What was the second part?
And then does your backend, do you have like a live things test server that you hit and then make sure like the data comes back, or do you mock that out?
Right. And for the backend, are we mocking data or using production data? So on the backend, we are actually querying our production data, but it is a replica. So everything that we would expect from production data is what we would see from our smoke tests. We also have mock data for our unit tests, which is just basically what you'd expect, mock data. Thank you. Yeah.
You're good. I'm just curious, like, how long did it take to hammer out the requirements for this, and like, how did you get your product people on? I don't know how big teachers, but how did you get your product people on board? It's like, well, we have a working search bar, you can blah 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 blah. So I'm just curious how you did that process.
So that process was fairly long, and we are still porting pages over. So the process is ongoing. But to basically have an agreement, a hunko, is what we call at TPT, is that there's a spec written on Elixir. Golang was one of the languages that we were looking into doing, also PHP 7. And that took quite a bit of time, maybe about a month. We all finally agreed in the summer 2 years ago. And that whole being able to prototype with Autosuggest after we decided was really important for us.
So a month for the requirements?
Just about.
Oh, okay.
Yeah.
Thank you.
Thank you.
No more questions? All right, thank you.
Thank you.